Consider a universe in which we're going to work in this video. So let us think of this as a blue universe. And in this universe, let's say we've got three sets, A, B, and C. And let's say A is an element of B, and B has no other elements except A. And B is an element of C, and C has no other elements except B. And let us say that A is a set that has no elements. Okay, so the concept that we want to introduce in this video is that we can identify collections of sets by writing down mathematical formulas, and then when we write down a mathematical formula, we can pick out all possible sets that satisfy that formula, in other words, for which the formula is true. So the formula has to be a formula about a set, and then we pick out all those that make the formula hold true, and by picking these out, we will get a collection of sets. So let's look at an example of a formula which says that a set needs to have an element. So I'm going to now make space for writing down the formula. So meanwhile, you can maybe think, how would we write down a formula stating that a set has an element? So it has to be a formula about a certain set. Let's call the set X. And now we want to say X has an element. And the way we can do that is to say that there exists a set Y. So all the variables in our formulas when we work with universes of sets are going to represent sets. So when I write Y down, it means it's one of the sets in the universe. And so I'm going to say now that there exists Y such that Y is an element of X. So this is a formula with one free variable, X. Free variable means that the variable X does not appear under a quantifier. So it's actually a statement. It has a meaning. It's a statement about a certain set X. And the statement can be applied to various different kinds of sets. And now we're going to apply to all possible sets in the universe. And then we're going to pick out those sets for which that statement is true. So by applying, of course, we mean that we substitute in the place of X, we substitute a specific set. So let's begin with C. If I put C in here in the place of X, I'm going to get a statement saying that C has an element. And in this universe, indeed, C does have an element, so this statement is true for C. On the other hand, if I pick B for the same reason, because B has an element, this element is A, the statement is true for B as well. But for A it is not true, because A does not have any elements. So there are only two sets in this universe, B and C, for which this statement is true. And so now we want to make a region in the universe of sets consisting of all possible sets for which the statement is true, for which the formula is true. And in this case, in the case of this formula, it's region consisting of just B and C, so we get this way a collection of sets. And let's indicate that by coloring in with the white color, because this collection actually doesn't form a set. There is no set whose elements are exactly B and C. So we get a collection still, but not a set. And there is a specific way in which we're going to denote this collection coming out from the way it was formed. Namely, we're going to write it like this. We're going to use these curly brackets, and then we're going to say, okay, we're now considering collection of all possible X sets such that, so there's has to be a condition on X by which the X's have been selected, and the condition is this formula, so such that there exists a Y such that Y is an element of X. So opening up this curly bracket and closing the curly bracket represents that we are forming a collection. And sometimes when this collection does form a set, then the set will also be represented with the same notation. And now in this case, so we've got on the left hand side, so there's a vertical bar. This is an important point in the notation. There's a vertical bar on the left hand side, whatever sense on the left hand side of the vertical bar, it shows us the objects that are in the set, but these objects can be represented by general letters, and then whatever sense on the right hand side of the vertical bar, that describes the condition on which the objects of this kind have been selected. So in this case, the objects or the elements in this set, in this collection, are, well, actually objects in this collection, because since this collection is not a set, it does not have elements. So B and C are not elements of the collection, because the collection is not a set. So the objects of this set are all possible sets, and let's temporarily name each one of them X as we go through them. So they're all sets X such that meet this requirement, and the requirement is that X needs to have an element. So this is how we get that the elements of that collection, the objects in this collection are those X's which satisfy this, but now it's not so relevant that it's called X, so it's just a placeholder for referring to an object, a set in the formula. And if I now go through all the sets of the universe, A, B, and C, and check which of these three sets meet the requirement given by the formula when they are substituted in X, so these are B and C, then that's how I get the members of the collection. So in this case, that collection, represented in the notation like this, consists of two members, B and C. And there is also another way of writing this down, so we can say it's equal to, and again use those curly brackets, and then list the members of the collection. So because in this case there are finitely many of them, we can do that. So we can list them and say, okay, it's B and C. There we go. So we've got here an example of a formula determining a collection. And this is how the collection as determined by the formula is denoted. And the meaning of formula determining a collection has been also explained in this video. We take all possible sets that meet the requirements of the formula. A little tricky point here is that the letters B and C themselves do not appear in the formula. The formula is about the general set X. So the X here is not a specific set, it's a general set. It's a variable that can change. The value can change. And when we try to verify whether a formula holds or not for a specific B set, such as B or C, what we do is we substitute in the place of X, we replace X with that specific set B, and then we do the verification. And in this example, we did the verification and confirmed that there are only two sets, B and C, that satisfy the formula, because there are only two sets that have an element. These are C, it has an element B, and also B has an element A, A does not have any elements, so the formula that exists y such that y is an element of A is not true. So that's how A did not get selected in this collection.